In this video, I'm going to demonstrate how to do the calculations involved with a Pearson correlation in order to estimate the correlation of 0.759 between stranger ratings of teachers and student ratings of teachers. And the formula that is going to do this in a miraculous way is the Pearson correlation, which is the sum of the Z scores multiplied together, divided by n minus 1. So this is the Pearson's correlation, and I've gone through the steps already through the foundation section of the textbook. So I'm going to assume that you've covered that already, and this is really just a practice run for you. So the first step is to calculate the mean, because I need to calculate Z scores. So the average for the stranger ratings of the teachers is equal to 2.5, and the student ratings of those same teachers was equal to 2.61. So the students actually rated the strangers a bit higher, at least numerically. We don't know if it's statistically significant between these two means. That's a separate chapter that I talk about testing the difference between two means. Next, I have to calculate the standard deviation, and I'm going to do that with the STDEV function. And so STDEV is standard deviation, and I've got to specify the data that I want associated with this standard deviation. So B2 to B12 equals 1.2059, and I want the same standard deviation estimate for students. It's going to be a different value, but the same standard deviation, C2 times C14. And the standard deviation is estimated at 1.50. So the next step after calculating the means and the standard deviation is to calculate the Z scores, and that's ultimately a big foundational element to the Pearson correlation is the sum of the Z scores multiplied together. So I need to calculate the Z scores for the stranger ratings, and I can do that here, and I'm going to use the standardized function, standardize, and I need to input the value x, which is the case's score, so B2, and the mean, which is equal to 2.5023. I'm only going to go to 4 decimal places, and the standard deviation, 1.2059, and that equals negative 0.18. And that's about what I would expect, because this raw score of 2.28 is a little bit less than the mean of 2.5. Because it's less, I expect a negative Z score, and it's pretty close to 2.5 though, so I don't expect a very large Z score. So this looks right. And then I can click the corner and drag to the bottom and get all the Z scores for each of the cases in the stranger ratings column. And I can push that to 2 or 3 decimal places, up to you. I'm going to call this ZX. And now I need to do the same thing for ZY. And so I'm going to use the standardize function. And I want C2, C2, and the mean, which is 2.6108, and the standard deviation, which is 1.150. So that's from down here. This is the mean, and this is the standard deviation. So I'm going to close that up and click OK. Click Enter, rather, and I've got a Z score of 0.529. So in this case, the student rating is 3.22 as a raw score, which is larger than the mean of 2.6, and that makes a positive Z score. And in this case, it's about half of a standard deviation larger than the mean. So I'm going to drag this down, and I'm going to get all the Z scores for each of the cases associated with the student ratings. So what's the biggest one? Out of curiosity, it's this one here. Negative 1.157 is the largest Z score because this 1.28 is much less than the mean of 2.61. So next, I need to multiply the Z scores together. So equal D2 times E2. And here are all the multiplied Z scores together. And we can see that there are some relatively large positive values. So we have a product here of plus 1.03. We have another, this is a really big one, 3.51, 1.44. So because there are so many positive Z scores, I'm really inclined to think that this correlation is going to be positive. And in fact, I estimated it in the previous video with SPSS at 0.759. So now I feel like I'm on the right track, and it looks like there's going to be a positive correlation here. So the next thing I need to do is I need to sum all of these products of Z scores. So I'm going to go up here, and then I get 9.09. The sample size is 13. So the last element of the Pearson R formula is to divide the sum of the Z scores, which I've done over here, and divide that by n minus 1. I'm basically dividing it by a value that's going to give me an average. So this is going to be like an average of the products of the Z scores, but I have to subtract by n minus 1, not n, because we know that that value gives us a better estimate in the population. So in this case, we have a sample size of 13 cases, 1 to 13. So I'm going to divide this value by 12. So equals F15 divided by 12. And that gives me 0.757, which is close enough to the SPSS estimate of 0.759 from memory, 0.758 or 0.759, somewhere very close to that. Obviously, there's still the last step of calculating the statistical significance of the correlation. I'm not going to do that right here. The purpose of this was really just to show you how to do the calculations to get the Pearson R.